although no, yeah. The explanatory power of the quantum mechanical model. So the chemical properties of elements are largely determined by the number of valence electrons they contain. We've been looking at how in the different columns in the periodic table, those elements are going to have the same number of valence electrons, at least in the main group elements. So the reason that the element properties vary in a periodic fashion is because the number of valence electrons varies in a periodic fashion. So this quantum mechanical model then explains why hydrogen is so reactive and why helium is so inert, and it also explains many other observations. So let's look at a couple of these groups or families in the periodic table. These are the noble gases over in group 8A. They have 8 valence electrons, or 2 for helium, because he's the baby brother of the noble gas family. So it turns out that having 8 valence electrons, or 2 for helium, is unusually stable. It's extra low in energy. These noble gases are very stable, and so they tend not to react with anything else. And so in my little chemistry fantasy world, these are the cool people in high school. They're in the in-group, they've got it all together, and they don't need anybody else. They're good. They're happy. Okay, so you got 8 valence electrons, that means you're happy. Well, what about group 7A? Group 7A has 7 valence electrons. They're almost there. And so they're actually very reactive, because if they could just get one more electron, then they would have that magic number of 8 electrons. The alkali metals in group 1A, they have 1 valence electron. What would happen if sodium lost its valence electron? It would have 8, and it would be like neon, and that would be particularly stable. So the alkali metals all have an NS1 electron configuration, and they're very reactive, because if they lose that 1 electron, then they go down to their core, and then they have 8 valence electrons again, because it's a little bit like peeling the layers off of an onion. If you had 1 electron in the n equals 3 level, and you get rid of that, you peel that layer off, and what's underneath? A full level. So the group 1A metals are going to form +1 ions, because by losing 1 electron, they lose that extra 1 on the outside, and they go down to the next level, and now they have 8 valence electrons. They have the same electron configuration as a noble gas. Do they become a noble gas? No, because electrons are like your clothing. It's on the outside. You can dress up like someone else. Halloween's coming up. You know, Andrew's going to dress up like a ninja. He's practicing dressing up like a ninja. Does that make him a ninja? No, he is still Andrew, the 4-year-old child with curly hair, okay? And a curly personality, too. So you can change the electrons. The protons are what make an atom a particular element. The protons are like your soul. They're your personality. They're who you are. You could do stuff to the outside of your body, and it doesn't change who you are. You may look different, but it doesn't change who you are. And so potassium has 1 valence electron. It can take off that 1 valence electron, and then it has the same appearance on the outside as argon, the next lowest noble gas. That appearance, that electron configuration, is particularly stable. And that's why the group 1 metals form +1 ions, because they lose that 1 electron and they form a +1 ion, and it's extra stable. And then we look at the alkaline earth metals right next door, beryllium, magnesium, calcium, those guys. They have 2 valence electrons. If they lose their 2 valence electrons, then they become like the noble gas. It's like, my mom made me wear this sweater to school, and it's really dorky. If I take the sweater off, now I'm going to look like the popular kids. Does that mean you're one of them? Not necessarily, but you can at least look like them, right? So magnesium's going to lose its 2 valence electrons to become like neon in terms of its electrons. Its nucleus doesn't change, though. So that's why the group 2 metals all form +2 ions. The halogens, they're right next to the noble gases on the other side. They have 7 valence electrons. If they could get one more, then they'd have 8. And so they tend to form -1 ions by picking up one extra electron. They have no motivation to lose an electron and become a positive ion, because that would take them farther away from that stable place. Okay, so they're not really trying to do anything because they're inert objects, right? They're atoms. They don't have personalities. But everything's trying in nature is trying to go to a lower energy. And so if they lose an electron, that's not going to be a lower energy state, so they're not going to do that. If they gain an electron, then they have a noble gas electron configuration, and that's going to be a lower energy state. And so there are advantages to doing that, energy advantages to doing that. So all the halogens form -1 ions. And the slides don't go into this, but like what about oxygen? What kind of an ion does oxygen form? What charge? 2 negative, right? Well, oxygen is in group 6A. It's got 6 valence electrons. By forming a 2- ion, it gains 2 more electrons, and now it has the same electron configuration as neon. So these main group elements are forming ions in a way that gives them a noble gas electron configuration. So these are elements that form predictable ions. So these guys over here, group 1, they're doing that, forming +1 ions, because when lithium loses one, it becomes like helium. It's the next lowest. These guys are going to lose 2 because it's 2 steps over. Really, the periodic table shouldn't be flat. It should be a cylinder with a spiral, just counting down. And so potassium should really be next to argon in this cylinder, because you go from 18, and then instead of jumping around, you go to potassium, kind of like the globe, right? There's no big seam between the United States and Eastern, I guess that's Asia over there, huh? There's no seam, but we always cut the map that way so that we can lay it flat. The periodic table is like a map of a cylinder, like our maps are maps of a sphere, a globe. And so it's just going over the other way, going across the date line. Don't push the wrong thing. Over here, these guys, fluorine needs to gain an electron to have the same electron configuration as noble gas. Oxygen needs to gain 2, and nitrogen needs to gain 3. And that is why they form ions with those charges. How many valence electrons does aluminum have? 3. It's in group 3. These guys form 3+ ions because they're going to lose that p electron, and they're going to lose their 2 s electrons, and then they're going to become like the noble gases. You may wonder, well, what about these guys in here? They're kind of stuck halfway between. They've got 4 valence electrons. They'd have to gain 4 or lose 4. And so they tend to do neither. They're like, it's just too hard either way. I'm just going to be a dork. Pretty much. That's what they say.